Hi everybody. So I'll just talk you through these notes on changing wave speed and how we solve problems on them. So the first thing we need to know is that the speed of the wave changes when it goes from one medium to the other. And what we need to keep in mind is that the frequency always stays the same. Okay, and the wave equation V equals F lambda tells us when the speed changes and but if the frequency is the same, the wavelength will also change. So if speed increases, the wavelength will also increase. Now there are several formulae we can use to solve these problems, and I've listed them here. V equals F lambda, which is the wave equation, or if you've got distance and time, you can still calculate speed. Frequency and period, F is 1 over T or T is 1 over F. Okay, now there are a few more equations and these are new, which we'll be learning the same thing in light as well. So I'll just explain this part because that's a new bit. So this diagram here represents a wave going from one medium to the other. This one is your fast medium. I'm just calling it medium 1, and it's going to a slower medium 2. So this dotted line here represents the normal, which is always drawn at 90 degrees to the surface. So I'll just indicate that. And so when the wave goes from a faster to a slower medium, the angle of incidence, that's your angle of incidence, is always bigger than the angle of refraction. It bends towards the normal when it slows down. Okay, there are some letters over here. So, and I'll explain what N stands for. So there's N1, which is called the refractive index of medium 1. N2 is the refractive index of medium 2. V1 is the speed of the wave in medium 1. V2 is the speed of the wave in medium 2. Lambda 1 is the wavelength in medium 1. Lambda 2 is the wavelength in medium 2. Theta 1 is the angle of incidence, this thing here, and theta 2 is the angle of refraction, that thing there. Now, N is called the refractive index. This is a new thing. It just tells us how easy it is for the wave to pass through that medium, how easy or difficult. In fact, it tells us how much slower the wave travels in that medium as compared to air or vacuum. So, for example, light travels fastest in a vacuum and it slows down when it enters glass or water or anything else it can go through. So that's what it is. And N does not have any unit because it's a ratio of two speeds. So ratios have no units. And then the thing is, scientists look for some connection between the refractive index and the angle. There was no direct link, but however, they found that N1 times sine theta 1 equals N2 times sine theta 2. They found when the refractive index increased, that means the harder it was for a wave to go through that medium, the more the bending happened. So therefore, smaller the angle of refraction. And so this is the formulae that is used, connecting all the refractive indices, wavelengths, or speeds, and you can use them in any pairs. You can use these two, or you can use these two, or you can use this one in combination with that, and this one here tells us any sort of pairs you can use for these equations. So I will upload this as a photo, and you can listen to it if you'd like to listen to that. Okay then, bye for now. I hope that made sense.